So our next talk is about a stochastic Petri net model of continuous integration and continuous delivery.
Good afternoon, everyone. I'm Sushovan Bhadra. This presentation is based on the modeling of continuous integration and continuous delivery.
There's the mouse. Sure, now try it. There you go.
Before I start to talk about CI/CD, let me explain why we need modern software development practice. Modern software development practice promise to accelerate the software lifecycle, despite increasing the overall complexity of the process to deliver the product faster to the customers. Nowadays, government companies and agencies and different industries who produce or acquire the software, they realize the importance of modern software development practice to deliver the product on time by maintaining the quality and the reliability of the final product. DevOps is the combination of software development and the process, while CI/CD forms the backbone of DevOps operation. CI/CD, it helps the developer to continuously integrate code in a single shared repository. It also automates the delivery process. Past studies, they use different kind of machine learning technology, AI, different kind of tool, framework, and model to improve different testing stages to make it automated. But none of them provide a direct insight how a comprehensive model of a CI/CD pipeline can help us to analyze the overall process performance. In this paper, I am proposing a stochastic Petri net model for the CI/CD pipeline. Here I propose an enhanced model that outperforms the traditional CI/CD pipeline in terms of probability of successful product delivery on time. We also did a sensitivity analysis to identify which stage can impact the overall performance of the CI/CD. This is a very generic CI/CD pipeline. This pipeline can be modified based on the software development company. Starting from the developer will do their coding in their unique coding branches. Whenever they are done, they will push their code in the version control, where a project manager will create a GitHub repository. Whenever the developer needs to make any changes, they will pull the previous updated version of the software and make the changes. Then it will go for the continuous integration test, while most of the tests are done automatically using Jenkins, Bamboo, or the GitLab, where all the code will be compiled and ready for the testing. For the integration testing, the software will be tested unit by unit. Then it will go for the integration test, where the overall performance of the software will be tested. And finally, it will go for the packaging, where the software will be compiled to a file format. After that, it will go for the continuous delivery. While most of the tests are done manually, that's why the performance are unpredictable. Starting from the acceptance test, where the reviewer will review the software from the customer's point of view, then it will go for the auto testing, while limited customer will test the software in an working environment. Then it will go for the deploy in production, and finally, it will be available for the final customer. Whenever there will be any bug or error find, it will go back to the developers to fix the problem. Let me explain what is a Petri net model. Petri net is a graphical model, mathematical model, which is used to model a complex process or to analyze the process performance. It is a bipartite graph with two subsets, place and transitions, where place and transitions are connected by the arc. A place can be both input and output place at the same time. Here is our proposed stochastic Petri net model for the CI/CD pipeline, where the places are totally identical to all the CI/CD stages. Here, the token represent a software which is under development. Place P2 and place P11 both represent the version control, where transition T0 to T8 represent the forward transitions. It means whenever a test is successful, the forward transition will enable and it will move the software for the next testing stages. T9 to T15 represent the feedback transitions. It means whenever there will be an error, it will allow the token to go back to the developers to fix the problem. Here we propose an enhanced model. Instead of for the auto testing, instead of going back to the developers for any kind of questionnaires or problem, they can have a conversation with the reviewer team at place P7, showing using the gray dash line from transition P14 to place P7, so that we can save some of our time for the software production. Here we did a performance analysis considering a deadline 150, which is an arbitrary number. It can be anything, 200 and 300, it can be anything. The black solid line represent the traditional model, the enhanced model graph, and the black dashed line represent the traditional model. By 150, the probability that the product will be delivered is 77.4%, while for the enhanced model, it improves to 80.02%. So we increase the timeline to see when it can reach the probability nearly to 100%. Our traditional model took 570 time unit, while our enhanced model reached 100% by 116 time unit. Due to the our enhanced model, the forward transition probability for the acceptance test auto and deploying production has been increased significantly, which improves the overall performance of the CI/CD pipeline. Then we did a sensitivity analysis. We reduced the failure probability in all the testing stages to see which stage can impact the overall process performance. Here we can see that failure probability in the later stage, auto test and deploy in production can impact the overall performance most. For the summary and the conclusion, here we propose to a stochastic Petri net model for the performance evaluation, while our enhanced model outperforms the traditional CI/CD pipelines, and it can reduce the delivery time by 10%. And the sensitivity analysis suggests that failure in the later stages can impact the overall system performance. This project is funded by WENR. Thank you. Thank you, everyone.